Welcome back. We are here for the last video in calculus with advanced functions. We're going to look at L'Hopital's rule. It's actually in section 7.12 of the textbook. L'Hopital's rule is going to help us in a very specific situation. And it's a situation that you've actually already seen. It's that situation when we end up with one function divided by another. We want to take the limit of the whole thing, of the quotient, but the numerator and the denominator are both equal to 0. It turns out that sometimes we can actually, and under certain conditions, which I'll define later, we can actually solve this by using something called L'Hopital's rule. So before I show you L'Hopital's rule, I'm going to remind you in an example what this problem is. We'll find the solution, how we found it, back in our introductory video. Then I'll show you how to solve it using L'Hopital's rule. Then we'll define the rule. After that, we'll go through a review of everything we've done in calculus with advanced functions. So here's the problem. We want to take the limit of this quotient, right? One function divided by another. We call that a quotient. And the limit that we're interested in is when x approaches 3. So for example, if I just let this thing be equal to 3, we end up with 0 over 0. Now, how can we get out of this mess? Well, one thing we can do is we can try and rearrange the numerator and the denominator algebraically so that we can eliminate this problem where we no longer have 0 divided by 0 when we take the limit. So if I look at the denominator here, I could write it like this, and then I could go, well, maybe I'll do this. 3. I've got a difference of squares here. So I've got x plus 3, x minus 3. The whole thing is divided by x minus 3. Notice that these are going to cancel out. Now I've got just 3 times x plus 3, and the answer is 18. So when we take the limit of this quotient and x gets close to 0, we actually get 18. So we didn't have to get 0 divided by 0. Now L'Hopital's rule says this: take the derivative of the numerator, take the derivative of the denominator, then divide the derivative of the numerator by the derivative of the denominator. So in English, that's what I'm about to do here. If I look, so maybe I'll define this as f of x over g of x. So if I'm looking for the derivative of f of x, I'm going to use the power rule. And if I'm if I look for the derivative of the denominator, I'm just going to get 1. Now I'll take 6x divided by 1, and finally I'm going to evaluate x at the limit. So I'm going to have f of 3 f prime 3 divided by g prime 3. And so I'm going to take this. I'm going to take this thing here, and I'm going to let x be equal to 3. And I'm going to have 6 times 3 over 1, because 1 is just 1. No matter what value x takes on, 1 remains 1. And so we get 18. And 18 is the same answer that we had doing it the old method, where we sort of rearranged, canceled out factors, and simplified it so that we could find the answer. Formally, this is what it looks like. In order to use L'Hopital's rule, we have to have two things. We have to have f of a equal to g of a equal to 0. Notice that a is where we're taking the limit to. Right? That's where we're taking the limit to. We also have to have the derivative cannot be 0. So it's not going to work if the derivative is equal to 0. Certainly not in the denominator. We definitely don't want the denominator going to 0. And you can see it's g here. So we don't want that denominator going to 0. Let's apply L'Hopital's rule for a problem that we were unable to solve earlier. So if I don't think we actually did this in the notes or in class, but if you look in the textbook and they're trying to determine what the natural exponent was, we have, or the derivative of the natural exponent, I should say, they have this formula. And notice that if we let x go to 0, we end up with 0 over 0. And also notice that the derivative of the denominator is non-zero. So according to L'Hopital's rule, we should be able to find this limit using L'Hopital's procedure, using L'Hopital's rule. So let's give it a try. I'm going to take the I'm going to look at the I'm going to take the derivative of the numerator. So I'll call that f prime x like I did before. We just get e of x, right? It's just itself. Don't even have to use the chain rule really. And the denominator, well, I already had it up here, is equal to 1. And so if I want to take the limit of this thing as x approaches 0, I'm going to write f prime of x over g prime of x e to the x over 1. That's just e to the 0, right? I want to let x equal 0. And that's just equal to 1. So the limit of this thing as x gets close to 0 is e is equal to 1. And if you go way back to the slides from the introduction to calculus, you can see that, remember, we were trying to, we did look at this formula because that was the one that we used to show why we need limits, because we weren't sure what was happening when x was equal to 0. Now with L'Hopital's rule, we know what we're going to see at the limit.